All right, I think we'll get started. I'm probably the last thing standing between you and either going home or going for a drink. You're the last thing standing between me and a drink, so I guess the Q&A might, but yeah, but people watching online don't know that. So my name is Dan Rosanova. I'm a program manager at Microsoft. I'm responsible for all the messaging services in Azure, and I'm here today to talk about Event Grid, which is a new service we have in preview right now, and really what that means for building applications and how your world as a developer or as an IT admin is going to look different because of this in the future. Real quick show of hands, anyone heard of Event Grid yet? Good, yay. Good, and if you haven't, hopefully I'll give you some background here. Quick public service announcement, please fill out the survey for feedback today. I'm assured you'll get swag. If you don't, it's not my fault, but I believe you will. There's the URL for it, so please take a minute before you leave. And I'm not offended if you leave a little early during my session, so don't worry. This is my second time here, actually. I came here last year. I've been to Finland twice now, last year was beautiful. It was nicer and warmer than in Seattle, but this is Seattle the day I left. It was, I think, 13 degrees. In your degrees, not mine, and sunny. And so it was quite nice. And this is what it was like when I got here today, or when I walked over here today. I actually thought this was interesting because I looked how to get to this venue, and the Maps app told me so many minutes walking and so many by bicycle. And I thought, who the hell would ride a bicycle in the snow? And 3 bicycles passed me during my walk. And I was like, oh, okay, I guess people here would. So I was a little surprised by that. And I actually like cycling a lot. I don't really cycle much in the rain anymore. I've never actually cycled in the snow. And for Mike, if he's around here, I actually thought Mammal was a middle-aged man in Lycra. But I guess not. Bold statement alert. I'm going to make a bold statement right now to start off my talk. And that is that Event Grid is not just a new service. It is actually a paradigm shift in how you're going to develop software. I'm not that smart. I didn't think of this stuff myself. It's a paradigm shift because we're copying another paradigm shift. But it is a bold statement, and I do believe it. So what we're going to cover today a little bit, where we came from a sort of software standpoint, and how we got where we are now. So sort of where is this whole idea of messaging and eventing in the cloud, event-driven development, and where we're going. So to get back in our time machine and talk about a little bit where we came from. Who here knows how to write code? Not that you do professionally, but show of hands, who here knows how to write any code? Okay, good, nice. Getting a lot more interactivity than I might have expected. So I know how to write code too, although I don't write too much anymore. I learned to program in, I guess, secondary school. And how I was taught was to use the analogy of a recipe. This happens to be from a recipe for one of my favorite dishes. It's a Rick Stein recipe for a sour tomato soup. So people tell you, hey, it's like a recipe, right? You follow these steps. First you do this, second you do that. That's procedural programming. That's probably how a lot of us learned how to program. And it's a good analogy. And then there are some things that we'll get into that make this a little bit funny. But I like food, so I like using the cooking analogy. I wanted to show the importance of organization, both in cooking and in coding or programming. But I didn't actually have a good picture that was copyright-free of cooking and preparation, so I used one of my own pictures of something else I love. And that is about organization. So mise en place, French term for getting your stuff ready before you start. It's how you avoid having a disaster in your kitchen when you're cooking, or when you're making a zombie in this case. This is something I would compare to structured programming. So this is quite structured. This has nothing to do with my talk, but it's my spice drawer, and I just wanted to show off how organized it is and how structured that is.
Great presentation.
Thank you. Yes. So here's the first part where the cooking thing breaks down. This step that I've highlighted in red actually says to cook until the seeds start popping. So there's no real time piece there. I don't really know when that's going to happen. I have to wait for the seeds to start popping. So computers aren't cooking, they're math. We'll get back to that in a second too. And we'll come back to cooking too. So in the era of the web and the cloud, how do things look right now? Where are we at? I'm glad someone brought up REST actually a few times today. REST and the web. I would actually argue that REST has been, who knows what REST is? Who's ever seen a RESTful service? Ever had to deal with one? Yep, okay. So I would argue that REST has been successful because it's really mimicked the inherent structures of the cloud. It's not that they invented something else. It's that the people getting behind REST looked at how is the web working and how can we make stuff that's going to work as well. So it's very successful, as is the web. And like the web that it's built on, it's all based around the HTTP protocol. And 1.1 and 1.0 of that protocol are pure request response. And no one's really using 2 yet. So pure request response protocols have inherent limitations. Anyone remember what the web was like 20 years ago? Like there wasn't a lot of responsive stuff, right? It was just very static pages. Seemed cool at the time. And so we actually came up with concepts over time to make that better, to make that experience better, make that experience more dynamic. And one of those was AJAX, which actually was in Mark's talk too. He didn't talk about it, but I saw it in his logs. So AJAX, asynchronous JavaScript and XML. There's so much there to love, right? So I'm not really going to talk about AJAX, but I'm going to talk about the problem that it solved. Anyone ever used AJAX or seen it or heard it? Yeah. So I'm not going to read this out. This is just from Wikipedia of what it is. But AJAX was a set of tools designed to bring you sort of asynchronous and responsive experiences inside of browsers, browser and web apps. So it's trying to make the browser seem less like a browser, like a 1990s web page, and more like a Windows application or a normal application you'd be used to with a real UI. So these types of concepts change the world that we know in software. In Windows, anyone who's written a Windows Forms application would recognize the first piece here, right? Button click, on button click. Anyone who is old enough to have remembered what it was like before Windows to write this kind of stuff would know what a pain it was. Or if you've dug down into what the Windows message pump is doing. A separate talk, I guess. And in the browser, we have the same things. You see the JavaScript stuff like on click, on mouse over. I love JavaScript because you can do either and it'll just work. And that's a joke. I actually don't like JavaScript. But it really changed the way that we build applications. And it's really made the experience of using applications more expressive. And now, actually, if you see like a page that's just sit there and stuck, or an app that's stuck and not responsive and not doing anything, you think it's broken. You think something's wrong, right? Our expectations have changed. It's like turning on a light switch. Now you expect the lights to come on. So these are all things that AJAX gave us that went right. But the ideas can also go wrong. And in particular, in AJAX, it's a polling-based concept. So it looks like it's asynchronous. It's not getting in your way as a user, but as a developer, it is getting in your way. It's making you call back all the time and see if stuff is done. And each of those polls requires a separate connection. So, that's okay at small scale, but it kind of breaks when you get to big scale. And to make a demonstration of that, we're going to take a little bit of a detour. And for that detour, I am going to need a volunteer from the audience. You don't have to get up. You don't have to say anything. It will be easy. Any volunteers? I'll just pick someone if no one volunteers. Someone? Anyone? I'm going to pick you. Okay. Don't worry. Yeah, it's fine. Does anyone remember who this person is? Leonardo Bonacci. Anyone know what this is? Fibonacci sequence. All right. So Fibonacci sequence is calculated by adding the two previous numbers together, starting with 1 and 2, each being 1. I'm going to ask you in your head, not out loud, not going to bother you, not going to hold you to it, to calculate the 7th Fibonacci number. Go. Are you done yet? 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 So that is a good example of what it's like to just be polling for something all the time. And it's kind of stressful, right? So instead of thinking about the Fibonacci series, you were thinking about me yelling at you. And that's what your server is doing too, when you're sitting there in that AJAX application hammering it. So this is kind of a good demonstration of what's wrong with non-reactive architectures. Thank you. Round of applause. So a little bit of background. I've always thought this was pretty funny that they chose the name AJAX for that. Anyone familiar with classics? Anyone familiar with the Trojan War? This is a big thing I was into when I was in primary, secondary school, I guess, with Greek mythology. AJAX was notable for his size and strength, and he was the strongest of the Greeks. He was undefeated in battle, recalling that the Trojan War was a 10-year-long war. That's pretty amazing to even live through that. And after the war, he went crazy and was conquered by his own sword, which is a euphemism for killed himself. So Ajax kind of does the same thing with your computer, too. Yeah, kills itself. So the next thing I'd want to talk about tied to this would be the reactive manifesto. This has been something that's it actually started in the web development world a little bit. Is anyone familiar with this reactive manifesto? Anyone read it before? If you've not, it's worth a read. I've got a link to it down in the bottom. And it really talks about how to build reactive software systems. And while it started in a UI-based context, it's relevant outside of the UI context as well. And that's that reactive systems are responsive, they're resilient, they're elastic, and they're message-driven. And so these are all traits that'll be the same whether you're working in a browser or whether you're working in 1,000 or 1 million browsers. So you're working at cloud scale or even like phone scale, single app. But this is how you can make applications that won't break. And one of my favorites is this one right here, right? Yeah. I love messaging. So if you're not careful with messaging, though, you can end up in some pretty nasty places. Yeah, if you're not sure, yeah, that's Dante in front of hell. This is what Event Grid is meant to solve. This is the problem we're trying to solve. So what is Event Grid and what's it trying to do for you? All of modern computing, especially when you get into the cloud, but even not in the cloud, all computing is distributed computing now. Very few things just run on your phone in complete isolation. They'll run on your phone talking to some services. They'll run on your browser talking to a lot of services. Actually, it's very interesting if you go open up like Fiddler or something and just look at when you load like CNN.com and see all of the stuff that's happening. It's really amazing what's going on there. Now, when you get to building applications and building them in a cloud environment, any cloud environment, there's really a lot of stuff going on. There are a lot of components to manage. You'll see everyone this probably conference talk about all sorts of different services. Any application is going to use a lot of them. A typical customer of my services uses 11.5 services in Azure. So that's 11.5 different things that are all doing their own stuff. And all of those have events going on inside of them. And what's tough about that is they all kind of handle that in a separate way. So if you want to know what happened in storage, you ask one way. If you want to know what happened in SQL, you ask another way. If you want to know what happened in your VM, you ask yet another way. So this is kind of cumbersome. This can kind of get in your way, cause you friction. And any of that friction is going to slow you down from actually being productive. So the idea behind Grid is to turn this around and make all eventing in a central place where it's easy to manage, easy to work with, easy to subscribe to, and easy to compose applications and services together. The idea here is really about event publishers and handlers. If you've ever done any sort of pub-sub messaging stuff, this will look a little bit familiar. There are some subtle differences we'll talk about. And the concepts here are really, there are 5. The first is there are events. What happened? A file was created. That's an event. The second is, where did it take place? So who published that? In the case of blob storage, that would be Azure Storage. The next is the topic. So where do the publishers, where does storage send that event? Finally, there are event subscriptions, which is how you receive events. It's how you express intent that you want to know about events. I want to know when something's created in this storage account, or I want to know when someone walks into this room. You know, those are events that you might be interested in. The last one's actually pretty interesting when you get into IoT type stuff. And then the last piece here is event handlers. Event handlers are really the app or service that you want reacting to the event. So it's usually something you own, not your cloud platform. So what is an event? This is an actual example of a storage event. Here you can see the relevant information you really care about is every Grid event is going to have this envelope, and I've highlighted the 3 pieces that you really care about, which let you subscribe for your intent to listen. The first is the topic. You can see from here, this is actually an ARM path. This is telling you it's what subscription it is, what resource group, that it's storage. You can see it says Microsoft Storage in there, the name of the storage account. There's a subject. The subject is, it happens to be in ARM stuff, which is all the Azure stuff, and we'll get to non-Azure stuff at the end of this. It happens to be the path under that ARM resource to the actual blob that this event is for. And you can see the event type is Microsoft Storage blob created. So this is kind of metadata about what really happened. And since this is storage, you'll see there's a data node here The top stuff, every event in Event Grid will have, whether it's from SQL or DocDB, Cosmos DB, sorry, the service formerly known as DocDB, and Service Bus, anything like that. The part and the data will be different. It'll be different based on the part and top. So it's really depends on what event type this is. And here you can see some interesting stuff that's relevant to storage, like the E tag for this, the content length, that it's a block blob, and the actual URL to the blob. An important idea with something like Grid is that it's a notification. It's not the actual file that was created. It's a shoulder tap. It's something that's telling you this file was created. If you want more information, go to this place and find out. So it's meant to be lightweight. It's meant to be very, very fast. Show the portal. Okay. Thank you, future Dan. So this is how this will appear in like a storage account or something. You'll see Event Grid on the left side here. I'm just in a storage account in Azure. If I click on Event Grid, it'll open up all of my event subscriptions that I have for this storage account. I've been trying to clean them out because I have a lot, but we can look at the ones that are here. And I can add one really easily just right here, Dan's new test, and figure out what kind I want it to be. I could say, hey, I want this to go to a webhook, like a webhook I own. I could also send this to an event hub. So I could say, send this to a log. Event hubs is like Kafka. It's a log service. For now, I won't make one of these, but you can see some interesting stuff here. Some simple stuff is that I can put the URL that I want to send this to, and I can put some filters on here, prefix filters. You notice that long path that was on there. I can actually say which parts of this path do I care about. Slash would be like everything or nothing. Blank would be everything from that storage account. I could also say this container within that storage account, and I can actually put suffix filters too. So anything in the storage account that ended with .jpeg or .csv or something like that. So this gives you a way to have some pretty fine-grained control about what you're subscribing to. And you notice some of these actually go to funny places that are outside of Azure, like PubNub. That's a good one. Kind of forgot that was there. So how this works, it's not just UI magic. We actually have a really cool model for how this works. This is a perfect talk to follow up on, since we've talked a little bit about ARM today, is that this is what's called a resource extension, or an extension resource in ARM. When you look at how ARM works, each service in Azure is going to have a resource provider of its own. So Microsoft.Storage is a resource provider for storage. What we do is we actually hang a virtual extension off of that. So when you want to use Event Grid, we didn't just make the UI look that way. It's the actual resource provider extends to support Event Grid. This is cool because it allows a couple cool things to happen. You actually talk to the storage provider to turn on and off events. You don't talk to some separate service, which would actually be a little bit more complicated. And behind the scenes, ARM forwards those calls to us. So there's not really much work for storage to do, and there's no extra work for you to do. And to see how this really kind of relates, I turned the extension green so you could see that. I'll actually show you what a raw put request, HTTP put request to Event Grid would look like to express your intent in a storage account. I've got it in two colors here. The blue would be the part that's just storage, and the green would be the extension that's Event Grid, so in the top half of this. And then at the bottom, you can see there's some data here, like I can say, hey, what's my endpoint type? It's an event, it's a webhook, it's at this address, and I want to do a filter that includes blob created and blob deleted, and have my begin with, my ends with, and whether or not it's case sensitive. The idea here is we're not changing. You should never see this stuff. These paths are just wonderful, you know. This is easy stuff to type. But your tooling will do this, and you're going to get a couple free things out of it that are good. The first thing is the last one listed here, is the management access control. So when you're creating a subscription on a storage account, because we're inside of ARM there, we can actually run RBAC against that request and see, do you have access to the storage account that you're trying to create a subscription for? And if you don't, we won't let you. So it's not like we need a separate authentication model. We're building into the authentication model that Azure already supports, which is RBAC through ARM. The next that's going to happen here is we have a couple aspects of security that I thought we'd go over real quick. One of them is webhook validation. How do we know, this is funny because we almost previewed without this. How do we know that the URL you gave us really belongs to you? We almost previewed this until we realized that we were about to give the world the largest DDoS cannon ever created. Our internal performance benchmarks for Event Grid are to do 10 million events per second per region in Azure. And you could have given us someone you don't like's URL and just gone crazy with it. And even funnier, since you can subscribe a lot, you could actually chain them together and get, create one blob file and fire off 1 million events. So we actually send a validation code in the request, and we require you to echo back that validation code. That is our security measure to know that you are who you say you are, that you own that URL, and you have permission to do that. It's a good one. So for event delivery, when you want to have us call your webhook, we do give you the option, it's completely up to you, of putting a query string token in your query string so that you know that the webhook coming to you is authenticated. It has the secret that you expect it to have. The query string token thing is pretty common in the push API sort of space. And we want to make sure that in the webhook space, we want to make sure that people know that's how they should be doing this. When you create a subscription, we're actually verifying that you have write permissions on the resource that you're subscribing to. I mentioned that as the access control thing. And then finally, when you're publishing to a topic, when you publish to us, because you can have your own topics if you want, and we want you to, but there are also system topics or built-in topics like storage, like SQL, like other things. When you publish to a topic, you need a SAS token or a key to do so. It's just a fancy way of saying you got to give us a secret that you have. If you're storage, you use a different authentication model, which is not really relevant today for us to discuss. So what can you do with Event Grid? Now that you know a little bit of what it is. There are really 3 scenarios we're going after. The first one is serverless apps, and I'll shotgun through that pretty quick. But the good example here is triggering a function when something is added to storage. This was possible before Grid. Did anyone use the old blob triggers in functions? Show of hands. Was anyone happy with them? Okay, there you go. So there are other ones too, like automation, ops automation scenarios. These are pretty interesting too. We think this will be pretty big. We actually suspect that this might be bigger for a little while in the first scenario than serverless apps. And then the last one is third-party integration. So you want to maybe use events at an application level, like sending a drive start event when your car starts moving, sending a drive end event when you turn the car off, things like that. Places where you want to have your own sort of events rather than system-level events, application-level events. In the serverless scenario, we have a really good sample here. I'm not going to walk too much through it, but it is in our documentation page today. It's a good example of using event hubs, which we talked about, capture, which you saw this morning, and triggering functions from that. So rather than pulling a storage file and a storage account and seeing for new files, event hubs will actually publish events to Grid, and then you can route them to whatever you want to process those. In this case, a function. It's cool because it's showing you how would you take your streaming data and move it into a data warehouse, which is probably where you want to get the data eventually anyhow. Nice part about this sample is that you don't even have to read from the event hub. Capture just does that for you. And it's cool to see how that works, because at first I actually didn't know how important this would be, but once we actually wrote it and built it, it turned out to be more useful than I thought, because here is what a event hub's capture event looks like. Again, it's got those 3 things I told you it would have: the event type, what thing, what resource it came from. But it's got some other cool data. This is different than what you saw in storage. It tells me that this is a block blob and that it's at this URL. That's important because we also support ADLS as a storage destination for capture. And then it tells you metadata about the file, the captured file itself. Rather than telling you file stuff, it tells you things that are interesting from an event hub's perspective, like how many events are in here, how big is the file itself, what is the lowest and highest sequence number of the events in this, which partition it came from, and the NQ times for the first and last event. This lets you make some logical decisions when you're processing. It was brought up earlier how capture events will write even an empty file. This is a perfect way to see, are there 0 events in this file? Then I don't care about it, or I can go delete it. When you get into ops and automation type scenarios, interesting here is if you think about being responsible, who runs applications? Who's responsible for running applications in your organization? Like from an IT sort of standpoint, like just making sure they're running. No one? Well, God, I'm working in the wrong country. If you were responsible for running applications, you'd probably want to know when someone changes them, because that's when things tend to break, is when people change things. And everyone always says, no, we didn't change anything. So there are a few ways to look at this. You get management plane operations that'll change stuff, like did people deploy things? Did they change resources, add or delete resources within a resource group? Were there security things? So did people log in? And then the last set of things you would get would be data plane changes, like did someone create a new blob? Did someone delete the old configuration blob that was there? So Azure's got a good story for this. Azure Monitor can actually watch all your resource data plane or management plane type stuff, and Grid can do all of your data plane stuff. So like, did someone change the config file that we're using to boot up all of our servers? This is a cool story for this composition type stuff. I think this will be pretty exciting. One thing I wanted to talk about real quick was the publishers we have today. We are almost out of preview, but what we have today are blob storage, Azure subscriptions and resource groups, event hubs, and custom events of your own. What we have as publishers, you can subscribe to these things today. What we have for subscribers, as first-class subscribers, are Azure Functions. So there's a full portal experience and tooling experience to build functions reacting to events in Grid, storage events, event hubs events, other things. Logic Apps integration is actually really slick. It's one of my favorite ones. Azure Automation, which really supports this sort of DevOps type scenarios. Webhooks, which is just basic generic webhooks, and event hubs so that you can keep a log of all of your subscriptions. What we have coming soon is pretty much everything in Azure, and then some things beyond. Service Bus will be both a source and a destination. So I gave myself $5 there, Mike, for bringing up Service Bus. And I guess one question you might have is, how is this different from my other toys? Because the other services I'm responsible for include event hubs. So anyone familiar with event hubs? You should be, since you saw it this morning. But I'll ignore that. When I talk about event hubs, I would tell people think about Kafka. Is anyone familiar with Kafka? So this means that it's a streaming platform. It's really meant for having many publishers sending data and telemetry, things like that. And it's going to have few readers. So there's some semantics here that are important. And it's ideal for big data workloads. So you're really thinking, how do I pipe data from one place to another? I might have thousands of things sending data, and I want to look through that stream of data and do some logic or processing on it or save it somewhere. That's what Event Hubs is for. If someone in your organization is talking about Kafka, you should be thinking about Event Hubs because it's fully managed. Conceptually, they're very similar. It's partition consumer model. Service Bus is a little different. Anyone familiar with Service Bus? You probably heard it 100 times from him. I didn't bring my checkbook, sorry. So Service Bus is really a business transaction queue. This is something that's like IBM MQ. I would assume everyone knows what IBM MQ is. It's been around longer than I have. Service Bus is something that's going to give you instantaneous consistency. It's really meant for giving you deep messaging, temporal control. Different from Grid. Grid is meant that people will come up, express intent in your events, and be able to subscribe to them pretty much without talking to you. In things like IBM MQ or Service Bus, that's not going to be the case. You're going to know where the messages are going ahead of time. You're going to know they're going to some billing system or some CRM or fulfillment or ERP. You're going to know all this stuff, and your messaging is going to work that way and depend on it. Service Bus is really ideal for transferring money and material. So if you think about moving things physically around or financially around, that's where you want Service Bus for. But Service Bus is actually going to support Event Grid as a event source. And so what we're trying to do here, the scenario here would be something like you have a lot of queues or subscriptions. So there's a lot of stuff there. This is actually kind of just like what would go crazy with Ajax. You want to react to it with something that's serverless, like a logic app or a function. And you want to deal with having sparse messaging. Maybe your traffic falls off at night, so you're not doing anything after 5 p.m. And you don't really want to pay for the cost of polling after that. You really want an event to just tell you, hey, wake up, there's stuff in a queue. And that's exactly what we're building. It's almost out now, so that will answer questions for people that want that. There are some good questions for why to do this. My personal opinion is that when you have to long poll, long polling is a place where you can just ask once if you're done calculating that Fibonacci number, and you'll just return me the result when you're done, but I have to wait until you're done. It's useful, but long polling when you get into the serverless context really puts the server back in serverless, which sort of defeats the purpose defeats the point in the first place. So if you look at like a function or a Lambda, they're designed to have a finite lifetime. Something that might take 8 hours is not a finite lifetime, or something without a finite lifetime won't fit in that model. This is a completely unnecessary picture of Seamus. That's my dog. I put him in every presentation, so I just put him in this one before I get back on track. And you can also see my other cooking love in the background. That is one of 2 bars in my house. So Event Grid, where are we going? Anyone recognize this picture? Yeah? I took this yesterday at the airport. I love this. It looks like it should be in a Craftwork video. So where are we going with Event Grid? One thing I wanted to point out is nothing requires any of your webhooks or any of your stuff that responds to Grid to be in Azure. You actually saw in my own Azure subscription that I had something called PubNub listening to that. That's a different cloud provider that's got its own serverless platform. There's another cloud company in Seattle you might have heard of on the other side of the lake from us in Redmond. We in Redmond, Microsoft. And nothing stops you from using their serverless platform with Event Grid as well. So we definitely think that things will be cross-cloud in the future. We're working on GA. It's coming very, very soon. I cannot tell you because I've been sworn to secrecy. I already told you Service Bus is a publisher is coming. IoT Hub device lifecycle events are on their way. So anyone playing with IoT Hub or using IoT Hub? A couple people? Yeah, so are you familiar with what device lifecycle events are? I'm not really, I'll be honest, but I can imagine. So those are coming. And one thing I can say is that every service in Azure will be producing events for Grid. These are not meant to be telemetry and logging. We have a good story for that. It's called Azure Monitor. It's what you should be using for that. This is meant to be stuff you want to react to, like someone deleted my database. That's a little bit different than someone logged into my database. Yeah. That one produces its own events. Yeah, exactly. And our vision for this goes beyond Azure. Azure is a pretty big thing, but there's more to Microsoft than just Azure, which is really hard for me to believe since I work in the Azure org. But apparently we have other things like Office 365 and Active Directory and Dynamics. But those are coming as publishers too, and we actually want your services to be publishers in Azure. Not necessarily with custom topics like we do today, but with something that looks like system topics as well. And we want other ISVs and cloud providers to be publishers as well. So there's actually a big move going to make, eventing will be big for all the cloud providers, not just for us. We're all kind of working together already to make sure we get a good story about that. So even if you're not in Azure, we still think there's a future for eventing in that. I'm coming up on when I wanted to end a little bit early so we have more time for the Q&A. So I just want to leave you with that it is a bold statement I made that Grid's going to change the way you build stuff, but I think it will. It'll take time to do that, but so did modern UI programming take time. So give it a try for yourself. It's in preview now. We are in 8 US regions, and later this month we will be in 2 European regions. Yeah, have fun with it. And I already asked you once, please fill out this survey and do it before you leave today. I'll do it myself right after this. If you have any questions about Grid, please come and see me. Thank you very much.